All right, class, welcome back. I know we just covered this today, section 3.4 in class, but I know we had some more questions. So using the guided notes, we're going to talk about what the slope of a line is. Okay, the slope of a line is just the description of as I'm running across this XY coordinate system, how much am I rising or falling? Okay, and so basically the slope is just what is the difference between the y points and what is the difference between the x points. And I describe that using the numbers, or the change in y over the change in x. The way you write the change in y over the change in x, we use the variable m to represent slope, so it's a substitute for the word slope. So if you see m, that means slope. And the way we calculate it is we literally say, well, what is the difference between these 2 points, the change in my y? So from here to here, what is the difference in the y's? And from here to here, what is the difference in the x's? Okay, so that is how we define slope. These subscripts of the 2 and 1 just literally mean, like, if I'm given one ordered pair and a second ordered pair, that those go together. So again, this represents one ordered pair, and this represents a second ordered pair. Okay, so how is slope calculated? That is through using this slope formula here. Okay, and then as far as slope goes, if your line is slanted upward from left to right, no matter what, your slope is going to be positive. If your line is slanted downward from left to right, no matter what, your slope is going to be negative. If your line is vertical, there's going to be no slope. And if your line is horizontal, the slope is going to be none. We have no slope there. Okay, so first off here, we want to interpret the following slopes. So if I have a slope of negative 1/4, what does this slope mean? Or if I have the slope of 2, or the slope of 5/3, or a slope of -5. So what do these slopes mean if I were given these values for slope? Okay, well, again, the top number is going to represent whether I'm going up or down. Okay, so the top number tells me up or down. Let me give myself more room here. Okay, I'm going to go up if it's positive and down if it's negative. The bottom number is going to tell me whether I'm going right or left. I'm going to go right if it's positive, because right is the direction for positive x, and left if it's negative. Okay, so sorry, we'll just start here with this one. I think that I wrote b is 2. Okay, so this slope here, negative 1/4, what this means is that for every unit I go down 1, I'm going to go right 4. So for every unit I go down 1, I'm going to go right 4. So if I had a point and I was right here, say from this point, this literally means I'm going to go down 1 and right 1, 2, 3, 4. So my next point would be right here. And if I were to start right here, it would mean I would go down 1 and right 1, 2, 3, 4. Okay, and I could do this all day long, go down 1 and right 4, and down 1 and right 4, and you'd see that this line would go on forever. Someday I'm going to figure out how to draw a straight line that goes through the points that I have. Okay, there we go. Okay, and you can see that this line could just keep going on forever. But the slope, again, this is a negative slope. There's a single negative here. So this means that I am going to be moving in the negative direction. Okay, or downward. This line is going to slant downward from left to right, but given some point that I'm starting from. So we interpret slope from a given point. Now, right now we don't have a given point, but we know that from that point we would go down 1 and right 4. But what if instead I wanted to think of this as 1 over negative 4? Well, how would this be different? Well, this would say then that I would go up 1 and left 4, which is great. So let's say that I'm starting at this point. I'm going to go up 1 and left 1, 2, 3, 4. Well, that's this point. Now I'm going to go up another and left 1, 2, 3, 4. And that would be this point, and so on. So it doesn't matter whether the negative is on the top or the bottom, but it can only be in one place. If it's on the top, then I'm going down. If it's on the bottom, I'm going left. Okay, and that is based on if it's the top number is negative, I'm going down. If the bottom number is negative, I'm going left. Okay, so that is interpreting that slope. Well, let's interpret then this slope of 2. Slope of 2, I'm going to scoot this down here, is just, there's no top and bottom, so I need to make a top and bottom. Remember that anything divided by 1 is itself, so I can just put this over 1. Now note here that this 2 is a positive 2. That means that no matter what, whether I think of it as back and back, or I think of it as forward and up, or whatever, however I think of this, this line will slant upward from left to right. This means that I'm going up 2. So from whatever point I start on my line, whatever that is, I'm going to go up 1, 2 from that point and right 1 to get to the next point. Okay, so that is my slope. The other way that this could be negative is if these, or positive, is if these were both negative. If these were both negative, then that makes this number positive. But again, this means that I'm going down 2 and left 1. So I want to show you again, say like I was starting at this point right here. To go up 2 and right 1 is the same as if I started at this point and I went down 1, 2 and back or left 1. So it wouldn't matter how I interpret this slope. But again, if it's positive, it's way easier to just think positive, but this is the same thing as this, but I wouldn't think too much about that. Okay, so for this example of C, if the slope was 5/3, well again, this is a positive slope. So that means this line is going to slant upward from left to right. This means that from whatever point I'm starting at, which we don't have yet, is going to be up 5 and right 3. Okay, so for every 5 I go up in Y, I'm going to go right in 3 to get to the next point on the line. Okay, and D, I believe I did, I don't know what I did a second ago, but let's just do -4. No, let's do, I think I did -3. Okay, and again, this -3 is the same thing. Anything over 1 is itself. So to get a top and bottom, I'm just going to put it over 1. This negative says I'm going to go down 3 for every 1 that I go right. So I'm going to go down, whatever point I start out, I'm going to go down 1, 2, 3, and go right 1 to get to my next point. Okay, but what if you wanted to see this as the 1 is negative? Well, this is going to be up 3 and left 1. Okay, so if I start here and I'm going to go up 1, 2, 3 and left 1, you can see that the positioning of these lines, whether I interpret the slope as up or down, as long as I move the correct right or left, it's still going to be sloping downward from left to right. So that is interpreting slopes. Okay, the next thing we want to do here is calculate the slope of a line given 2 points. All right. So given the points 3, 1 and -2, 4, what is the slope of this line? Sorry about that noise. Okay, so what is the slope of this line? Well, I'm going to plug in points. And if I'm going to use this these are the two ordered pairs. If this is my ordered pair 2, so I'm going to label this my second ordered pair and this is my first ordered pair, then this is the value of y2. y2 minus y1 over x2 minus x1. Again, I'm just plugging them into this formula right here, the slope formula, and these are my values: x1, y1, x2, y2. So I'm going to substitute where y2 is the value of 4, where y1 is the value of 1, but the relationship here is subtraction. Okay, so what I get here then is 4 minus 1 is 3. So this is the difference, or the distance that I traveled in my y direction. I traveled up 3. Okay, and then negative 2 minus 3 is a negative 5. Okay, so the way that I could interpret this could be two different ways. I could say I went up 3 for every 5 that I went left, or I could say I went down 3 for every 5 that I went right. Either way, we know, because this is negative, this slope is negative, that this line slants downward from left to right. Okay, and again, the change from whatever point, so if this was my point, I'm going to go up 3, 1, 2, 3, and left 1, 2, 3, 4, 5. Or I could say I'm going to start at this point as well, and I could say I'm going to go down 1, 2, 3, and right 1, 2, 3, 4, 5. Whatever these points are, then you could see that this would make a line. Okay, this problem is not asking me to do all of this, it's just saying find the slope, which we would say is a negative 3/5. Where that negative is does not matter. Okay, so for B, let's do the points 1, negative 5, and negative 3, negative 5. Okay, so again, this just represents an ordered pair. Which order you do this in doesn't matter, so I could say that this one is my x2 and this one is my y2. As long as this ordered pair is together, this is my second ordered pair, as long as I use this as the ordered pair together, it doesn't matter which one I label which. Okay, so if my y2 is negative 5, I'm going to subtract my y1, which is also negative 5, all over x2, which is 1, subtract x1, which is a negative 3. When you have those double negatives here, we're going to add. So I get negative 5 plus 5 is 0, and 1 plus 3 is 4. Well, this then means, remember that anything, or 0 divided by anything, is still 0. So my slope here is 0. What this means is this line is a horizontal line. There is no slope here. Okay, and I can see that by looking at these points. My y value does not change. My x value changes, but the y doesn't. When the y does not change, then this means that y will always be negative 5. Now again, this problem is not asking me to write this equation, it's just saying to find the slope. So this is the answer to this problem. But visually, I want you to understand what's happening here. If there's no slope, you've got a horizontal line. If that's the case, what is the equation of that line? Well, the equation of that line will always be this point, whatever that point is. So when the y doesn't change, that's what y always is. Okay, so that is our B example. Just making sure I'm still recording. So let's look at another example. C. Let's say that we have the points -2, -2, and 3, and a -1/2. Okay, so these are my given points. I'm just going to write these tidbits here for us to remember. Okay, so I'm going to take my y2, which is going to be -1/2, and I'm going to subtract y1, which is -2. Then I'm going to take x2, which is 3, and subtract x1, which is also negative 2. All right, so this can get a little bit tricky, but again, I'm adding these. So on the bottom, no problem, I have a 5. But what do I have on top? Well, if I want to add these together, I need to make the same denominator. Okay, so up on top here, what I really have is negative 1/2 plus 2/2. Sorry, 4/2. 2 times 2 is 4, 1 times 2 is 2. Okay, so 1/2, negative 1/2 plus 4/2 is a 3/2. Now this slope, this is confusing. It's like, what? WT, we'll say H, just to make this a little PG rated. Okay, so what this literally says though is 3/2 divided by 5. So to find this slope, I can't move in 3/2. I need both of these to be whole numbers. So what I'm going to do then is I'm going to write this out. It literally says 3/2 divided by 5. Well, this 3/2 is going to stay, and I'm going to copy dot flip, and then I'm going to multiply straight across the top and straight across the bottom. So I'm going to get 3/10. Okay, now this is a slope that I can interpret. So this here is my slope. This is a positive slope, and it means that for every 3 I go up, I'm going to go right 10. Okay, so that is the slope of the line C. For D, let's do the points -3, 0, and -3, 5. Okay, so all I want to do here is find the slope. So I'm going to take my y2 value and subtract my y1 value, which is the 0. I'm going to take my x2 value and subtract my x1 value, which is right here. 5 minus 0 is 5, but 3 minus a -3, or -3 plus 3 is 0. And remember that anything divided by 0 is undefined. So that means my slope here, I have an undefined slope. Okay, so the slope here is undefined. And what this means, okay, this is the answer to this question, find the slope. What this means is that I have a vertical line. Okay, if we were to graph these points, -3, 0, and -3, 5, this line looks like this. And you can see here that every x is the same. X does not change. When x does not change, that means that x is always -3. And this would be the equation of this line. But again, this question is only asking you to determine the slope, which is undefined. But you need to make the connection that an undefined slope means I have a vertical line. I have a vertical line means I have an x equals equation. What is that x equals equation? In this case, it's -3 because that never changes. Okay, so last couple of exercises, let's find the slope and the y-intercepts of each of these given lines. So we're just identifying the slope and the y-intercept. So now we're talking about something, the lines, but we want to put, we can only identify the slope and the y-intercept if it's in slope-intercept form. Okay, so to interpret slope, we have to be in slope-intercept form. Again, I want to emphasize that if the equation looks like this, or any other form of this coefficient of x, this is not slope. It's only slope when I have isolated and solved for y. Okay, so this is only slope when I've isolated y and there's nothing else on the other side. Then this is my slope. And this right here is the point 0b, which is my y-intercept. Okay, so you can't interpret slope unless you put it in slope-intercept form. So for this first problem, y is equal to 2x plus 1. Lucky me, this is in slope-intercept form. So because it is, I can find the slope and the y-intercept. The slope is literally just this coefficient right here. This is my slope. So slope is 2. My y-intercept, though, is not -1. The y-intercept does not equal 1. It is the point 0, 1. Remember that every point on the xy coordinate system has to have an x and a y value. The reason why it's 0, 1 is because if I plug in to this equation the value of 0 for x, this is what this says. This is the value of 0 for x. When x is 0, y is 1. This is a literal statement. Y is 1 when x is 0. Okay, so this is my slope and this is my y-intercept. Great, when that's in slope-intercept form. But what if it's not? What if it's in this format? So this is in standard form. This is not in slope-intercept form, so I cannot say slope is -1. What I have to do is I have to solve for y. Okay, if you want it to be able to interpret slope and y-intercept, you need to solve for y. So I want to get this x away from y, so I'm going to add it to the other side. What I do to one side, I have to do to the other. So 3y is going to be equal to x minus 9. I'm going to write the x first because I'm trying to put it in this slope-intercept form. Okay, so then I still have an isolated y. I need to get rid of this 3, but that means I need to divide everything by 3. So to rewrite this, those cancel, and I get y is equal to, the coefficient of x right now is 1. So this is the same thing as saying a 1/3 x, and then minus 3. It's important to note that right here, this could also be written as x over 3 minus 3. These say the same thing. Okay, so now that I have this in slope-intercept form, I can interpret slope. The slope here is 1/3, and the y-intercept is the point 0, and this b value right here, which is -3. Okay, so that is my slope, and that is my y-intercept. Okay, what if I have a function instead of it saying y equals mx plus b? Then what? Well, f of x is the same thing as y. You can substitute it for y. So this says these are the exact same thing. Okay, so this is in slope-intercept form. Okay, if this says the f of x. So this could say the f of x instead of y, which is totally fine. Okay, so it's already in slope-intercept form, so piece of cake. This means that the slope is 1/4, and my y-intercept is the point 0, and whatever this number is right here, which happens to be -5. So just identifying my slope and y-intercept. All right, next problem. I want to give you lots of examples here, so hopefully you can grasp this concept and feel confident and understand what we're talking about here. So this is not in slope-intercept form. Okay, this is not standard form either. It's somewhere in between, but I want to solve for y. And when I solve for y, what I'm going to do then here is just divide by 3. So y is going to be equal to 2/3 x. Okay, so now that this is in slope-intercept form, I can identify my slope and I can identify b. But notice there's nothing here. All right, so slope is 2/3, and we've talked a lot about how to interpret that slope. But my y-intercept here is the point 0 what? Well, there's no value here, so it's the point 0, 0. When there's no b, this means that this equation goes through the origin, the point 0, 0. Okay, so it only crosses the x and y axis at this point right here. That's what that means. And then we'd go up 2 and write 3. This equation would look like this. Now this isn't asking you to graph, but just want to make sure that we understand that when there's no b, my y-intercept is goes through 0, 0. Okay, these next two are going to be a little tricky. So I have the equation y equals -6. I'm supposed to be identifying the slope and the y-intercept. There's no x here, so I can't identify the slope. And maybe this is b, I don't know. But what does this line look like? Remember that y equals a number is a horizontal line at the point y equals -6. This means that every time, no matter what, in my ordered pair, the ordered pair has -6 as the y value. So we could do this as like 2, and we could do this as like -5. Okay, so at at 2, the value is -6, and at -5, the value is -6. So no matter what, y is -6. That's what this says. So this is not intuitive way to, like, you can't just be like, oh, blah, 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 unless you memorize this, that a horizontal line has no slope. You can see that here. There's no slope. It doesn't rise or fall. It just runs. Okay, so there's no slope. What I'm asked to identify here is the slope and the y-intercept. Well, the y-intercept is the point where this crosses the y-axis, which is the point 0, -6. Okay, so this is my slope, and this is my y-intercept. A little bit different. This is not in slope-intercept form. Again, this is a horizontal line, so you have to understand horizontal lines have no slope, and they cross the y-axis at the point that it says. So if this was y equals 3, the slope would be 0, and it would be 0, 3. Okay, what about if I have x minus 4 equals 0? Okay, well this doesn't even have a y, so how am I supposed to solve for y and put this in slope-intercept form? I can't. So what do I need to know about this? Well, let's put this in some form that we do recognize, that x is equal to 4. If x is equal to 4, x is literally always 4. Well, x is 4 right here. Let's do a few ordered pairs where x is 4, because that's what the statement says. X is 4. Well, x is 4 when y is what? Well, it doesn't matter, because there is no y. X can be 4 when y is -1, when it's 0, and when it's 2. Doesn't matter, but x is always 4. If x is always 4, 4 -1 is right here, 4 0 is right here, and 4 2 is right here. You can see that this creates a vertical line. And what you need to understand here, or make a connection, that your life will be so much easier when you make this connection, that x equals some number is a vertical line. It makes a vertical line, which means that the slope of the line we're looking at is undefined. Okay, well, what's the y-intercept? Question is, the y-intercept is where this crosses the y-axis. If this is a vertical line, is it ever going to cross this y-axis? The answer is no. This will never cross the y-axis, so there is no y-intercept. Okay, so if you have a vertical line, there's not going to be a y-intercept unless the x is the x-axis. Okay, but otherwise it's going to be parallel and never cross that y-axis. Okay, so next thing we want to do is talk about, we want to use a graph and determine the slope and y-intercept from the graph. Okay, so if you were given this graph, so if you were just looking at this graph and they said, well, what's the slope of this graph? Well, the slope of this graph, I literally pick any point on the line. So I've got a point right here, a point right here, and a point right here. So I can pick any point I want, and then I'm going to go to the next point. So if I were going to travel, say, let's just start with this one because it's easier. I'm going to go, oh, I went down 2 and right 1. Well, what is that? How do I write down 2 and right 1? I went down 2 and right 1. Well, the simplest way to write -2/1 is just -2. So this line has a slope of -2. Again, maybe you started here and you were like, no, I went up 2, but then you went left. Well, still, 2 divided by -1 is -2. So regardless, this line slants downward from left to right and has a slope of -2. That's to get from one point on the line to another, not anywhere else. One point on the line to another. Now, my y-intercept is literally where this crosses the y-axis. And that crosses the y-axis right here at the point 0, 2. Okay, so looking at this graph,